Hello, am I audible to all of you?
Yes, Nadia, you are audible.
Okay, good evening to all of you. I'm Nadia Naqvi, National Coordinator of the Foundation. And today we are here for our current talk, 10th lecture of current talk. And for today we are having a talk on material science for future application. And for this talk we are having Ms. Faria Naqvi, Senior Research Fellow, Department of Chemistry from AIMD. So, before starting the session, I would like to request all our participants kindly mute their mics and camera to avoid the disturbances. And if any one of you have any query regarding the today's session, you can put your question or query in the chat box, or you can also directly ask the speaker at the end of the webinar. So, ma'am, now you can share your slide.
Okay. Okay. If my slide is visible. Hello. My slide is visible.
Yes, your slide is visible.
Okay, shall I start?
Yes, you can start, ma'am.
Okay. First of all, thank you so much, Eco Foundation, for giving me this opportunity for presenting my work, my thoughts in front of you all. I make my presentation so basic. I know my audience comprises graduation level, master's level, and research level participants. That's why I make them more and more basic to clear my thoughts, my research to all of you. I'm Faria Naqvi, Senior Research Scholar, Department of Chemistry from AMU, and presenting my thoughts, my research on material science for future application. Well, what is material science and what do we mean by materials? Materials are comprises into metals, ceramics, polymers, composites. It is easy to describe these materials. And we can also say that if we look around ourselves, our clothes, our homes, vehicles, windows, metals, ceramic, dishes, all are comprises from all comprises materials, but all are of different materials. Materials are, we can say that metals, aluminum, steel, nickel, titanium, these are all also materials, ceramics, clay, silica, polymers, PVC, and in composites, carbon materials, and concrete, wood, etc. These are all the materials. But in material science, these semiconducting materials are more useful and they uh, give more applications in material research. Okay, here we can see the different figures of material. This comprises the gel-like substance, a solid substance, a fibrous substance, a translucent, a cloth-like, water, and a substance with different colors, a wood, a fibers, an insect, a silk fabric. These all are consist of material. These all comprises some kind of material in it. But these all are different kinds. Now, types of material. We have seen earlier in this slide, these are different kinds of material, but these materials are characterized in different types. Some are crystalline, some are amorphous. And between crystalline and amorphous, some are polycrystalline. Crystalline materials are actually materials having a regular periodic arrangement. I think these crystalline amorphous material everybody knows, but for better understanding, I'm explaining what is crystalline. These are containing one or more a regular period. These are containing one or more crystals. In each crystal's atoms or ions show a long range of periodic arrangement. They are anisotropic in nature. Here, in amorphous systems, materials do not have a regular period. As you've seen in this figure, they don't have a regular arrangement. Some like this, some like this. But in crystalline, they have a regular arrangement. But in polycrystalline, there is something like crystalline, a regular arrangement. There is an irregular arrangement. This is a regular arrangement. And because of this irregularity, these polycrystalline materials show a various application and various properties. And the properties are the mixture of crystalline and amorphous. Now, the crystalline, in previous, we say the crystalline, the 2D structure. These crystalline, the 3D structure array gives the material long range order. Okay. Then according to these packing of atoms in a system, they are divided into different kinds: simple, cubic, like body-centered, face-centered, cubic, hexagonal, tetragonal, orthorhombic, and various varieties of crystalline materials are present in the universe, or the material scientists are discovering different types of materials. This stacking of arrangement of these molecules define its property, its ductility. Okay, then non-crystalline amorphous materials are short range nearest neighbor order. These are viscous materials. These are isotropic materials, isotropic in nature. Few examples of crystalline and amorphous is most of the geologists knows what is galena, quartz, pyrite, everything. But these galena, quartz, pyrite are crystalline in nature. They have definite shape, definite geometry. This quartz have trigonal, hexagonal type of crystal structure, and this galena have cubic, sometimes octahedral, and this pyrite is cubic in nature. Everybody, I think, knows this, what is cubic and what is hexagonal. These are crystalline. They have definite geometry. Because of their geometry, the properties will be defined. And amorphous consists of foam, grain, sand, silicon pellets, bulk materials, biological tissues. These are all comprises amorphous. This glass is seen like a regular array, but this is not a crystalline substance. This is also comprises in amorphous. Now, but without materials, there is no engineering. We can sometimes we heard the name material engineering. Without materials, there is no engineering. Material engineers are still in the trying to discover new and new material with new and new properties. The simplest example we are taking here, the carbon and its electrodes. Everybody knows diamond, graphite. Everybody knows these allotropes of carbon, but these allotropes are made up of carbon. But these carbon, the arrangement of carbon in diamond and in graphite are different. And that's why the properties are also different. The hardest material is diamond, and graphite is softest if we compare to diamond. And the graphene is the most we can say that the amorphous type, or we can say that the most used material. the graphene shows various kinds of properties, various kinds of application. I'm not going through to the graphene properties because I'm not discussing the graphene here. Because if we are digging to the graphene, then this will very long, and we have a time limitation. Now, the material science. What is material science? Now we can understand what is material. Now, what is material science? The discipline of investigating the relationship between the structure and properties of material. What is the structure of that material and what is the properties of that material? Is this study is called material science. This material science are interdisciplinary. Various subjects are comprised in this: physics, chemistry, biology, geology, metallurgy, and everything is comprises in material science. Material science connects the real world problem to the real world material in an acceptable and economical way. This is necessary when we are researching something, when we are discovering something. It is necessary to make that discovery, to make that research more cheap, more economical, so that the normal mankind, normal man can take use of our research, can use or utilize that research. Now, what is the future of this material science? Okay, we are discovering the various material, we are researching everything, we are talking about its structures, we are talking about its property, but where is the use? Where is the use of this material, and how we can use this? In this, an effective example uh, for taking future of material science, an effective example is iron. We all are aware about iron and its use. Iron is considered as a strong material, and we can see that iron is everywhere in building material, in vehicles, in bridges, in trains, in railway tracks. Everywhere is iron, because we thought iron is the strongest material, hardest material, or strongest material. That's why we use iron. But this is not the case. Iron is not only because of its strongness, its strong behavior is used everywhere, but it is because of its properties. Its properties changes when we cool it, when we heat it. We can heat at high temperature, property changes. And if we change its structure from macro to micro to nano, these properties are changes in case of iron. But in case of silver also, another example we will take silver. The property of silver is also changes. Similarly in gold also. We are taking here silver. What we have seen silver. Silver is used as an ornament or as an utensils. Okay, but what we have seen, maybe I think everyone have seen silver foils. In the sweet, we seen the silver foil. Why this silver foil is used on the sweets? This is not because of decoration purposes. This is something antibacterial and antifungal. Silver is used as an antibacterial and antifungal material. When the silver goes inside our body in micro level, not in macro. We can't eat the silver bar, but in micro level, when the silver goes inside our body, uh, it shows the property of antibacterial and antifungal. And this is the beauty of material science, and this is the heart of material science, to ability to change the property and behavior of the material according to their shape, according to their size, according to their temperature. Okay. Now, the material science is comprises in the pyramidal form. What we, the scientists or researchers do, first of all, we will process and prepare the material. Some material we are interested in, and we process, and we can see the various type of synthesis processes, and we synthesize them. Okay. one step is completed there. Next, what we have done, what we will do, we will study its structure. Then its characterization. What is the structure of that sample which we synthesized? Then its characterization. Structure, I mean to say structure, arrangement of internal component. How it is arranged. It is whether it is crystalline, whether it is amorphous. If amorphous, whether it is in the range of macro, micro, nano. We will study in the case of structure. Next, characterization. In characterization, we study atomic level, subatomic level, microscopic level, macroscopic level. Okay. Then the properties. What are the properties which we synthesize? We synthesize some materials, and their properties are changes. For example, if we synthesize in macroscopic level, something in macroscopic level, what will be its property? But in mechanical properties, thermal property, optical property, what will be their properties? And if we synthesize the same sample in atomic level or nano level, what will be their properties and how it will be differentiated from macro level to atomic level? Okay, and how it performs. The last thing, how it performs. Is its performance is good or not? Next, this is the for your consideration, for your understanding the levels: atomic level 10 raised to power minus 10 meters, nano 10 raised to power minus 9 meters, micro minus 6 meter, macro minus 3 meters. This is the scale of from atomic to macro level. Okay. Then, now we are discussing about semiconductors. In the beginning, I said that semiconductors are very much used in the field of material science and in the field of computers and other things. The scientists or engineers are continuously design new materials with the with new characteristics of semiconductor materials. Semiconductors are used in various applications. And there is one method, XRD method, X-ray diffraction method, which we have done for physical parameters to find out its semiconducting behavior. Okay, this is for your understanding. This is the XRD graph, 2 theta. This is the degree versus intensity. XRD graph, and this is thermal differential thermal analysis graph. This is how we synthesize our sample, different samples, and from this peaks we conclude the what is the nature of our sample, what is the structure of our sample, what is the size of our sample. From all of these, from the calculations of this XRD graph, we can do this. I'm not going in detail with XRD because I know everyone don't understand the whole thing in XRD. Okay. Then next, this is the micrographs of SEM and EDX. SEM shows the spherical structure of the particles. Only the morphology, to find out the morphology, we have done the SEM characterization to see which type of particles here. We can see that it's somewhat spherical, and some other samples we have seen the cylindrical. Sometimes we have found out that particles are in hexagonal nature and other. Okay, and this EDX is for a particular region. We can find out what type of composition of our sample at that particular area. What is the composition of our sample? This is only for reference. Okay. Now we are discussing about semiconductors, where it used. And I said semiconductors have vast applications. But what are these applications? Semiconductors are used in photovoltaic cell. Photovoltaic cell has become the cheapest source of electrical power in the region with high solar potential. This is approximately 0.156 US dollar of cost. And this is the newest data of 2020. And outside India, in many of the countries, they use photovoltaic cells for domestic purposes. Here, how in photovoltaic photovoltaic cell, these semiconductors are used here. Here, these semiconductors are used. In this case, in this example, titanium dioxide is used as a semiconducting material, and here the metal electrode, here semiconducting material, and here this is the glass sheet. If anyone sees this solar panel, they can understand this is the glass panel. Here the synthesized semiconductor. This is the metal electrode. Okay, when the sun rays coming through this glass electrode to this semiconductor, it generates the electron hole pair, and the conduction is going on like this. This conduction is going on, and it generates electricity. Okay, next, this semiconductor is used in water splitting. Many of the cases we have seen the impure water. What we have done, we can split the water into its components, oxygen and hydrogen, with the help of these semiconductor. Here again, this semiconductor is used, titanium dioxide is used as a semiconductor. The same phenomenon, when the light, visible light or UV light is fall on this semiconductor, and this starts electron and hole pair generated, and it splits the water H2O into here the oxygen and here the hydrogen. It splits into oxygen and hydrogen, its component. Now next, the photocatalysis. In photocatalysis, the catalyst is the substance which catalyzes the reaction, any reaction. It only catalyzes the reaction without taking part in the reaction. Now here, semiconductor, same photons when come on the surface of the semiconductor, electron hole pair generated, and when the atmospheric oxygen come on this, and oxygen radical is generated, and hydrogen molecule is hydroxyl radical is generated, and the organic pollutant. Photocatalysis is mainly done for the pollutant to pure the water molecule, water bodies. The organic pollutant, mainly the organic pollutant, are convert into carbon dioxide and water molecule. Why it's converted in carbon dioxide? Because this is the organic, and organic is something carbon and hydrogen, made up of carbon and hydrogen. And yeah, I know somebody maybe ask, carbon dioxide is harmful, carbon materials is harmful for our environment. Yes, this is the demerit of this. Carbon dioxide is evolved to our environment. This is harmful, but our water bodies may be much cleaner than before. This photocatalysis are still in the research, and the scientists are still trying to boost this mechanism, and trying to split this carbon dioxide again to more constructive or something useful product. Okay, next. LEDs and LCDs. In LEDs and LCDs, we all are aware about LEDs and LCDs. This LEDs, light emitting diode, LCDs, liquid crystal diode. In past, we all have seen LCDs. These LCDs, in which we use liquid crystal in the panel, and this liquid crystal shows the image which we all have seen in the television. But these are now replaced by LEDs. Now it replaces the liquid crystal diodes, light emitting diodes replaces these liquid crystals, and this, because of these diodes, the image is much clearer and brighter as before, which was seen in LCDs. Okay, now in mining and minerals, maybe the geologists may understand how in mining and mineral the material science will be benefited. In mining and mineral, for example, if we are taking a case, if some geologists go to the survey or some field work, and they found something new or something unique thing, and he or she come back to its laboratory, his vicinage, and find out what it's composed of, some mineral or some rock sample, he collected, and he's curious about what this mineral or rock is composed of. And what he will do, he will give his material or his sample to some material scientist. What these material scientists do, he will take the sample and first of all, he conducts the structural characterization of that sample. He will study all the structures of that sample, what is the structure and what is the component present in that sample, what it is comprises of. It is made up of only one material, or it is a mixture of material. If the mixture, what are the mixture, what is the composition. After these studies, he will study further the properties. What is its optical property, its thermal property, its other thermal properties and other fluorescent material. Is it fluorescent or phosphorescent? Many properties, or it is semiconductor. If it is conducting, then how, in which range it was conducting, and what is the material present which make them conducting. Okay. Now in ceramic industry, in ceramic industry, like aluminum oxide, silicon dioxide, and these are all made up of materials. Aerospace and energy, automotive industries, consumer products like dishes, glassware, lenses of your spectacles or your eyeglasses. Now, in aircraft, next generation vehicles. Do you ever think that why is this space shuttle shaped this way? Why is this the shape of the space shuttle is like this? Because to reduce the amount of heat generated upon the entry when they enter to the space, heat is generated. That's why they made up of this shape. And this material can change the shape of next generation space plane. This type of materials, maybe next generation space plane, because of their unique combinations and properties. This material is also made up of some different kinds of composites. Now, advanced polymer application. I think everybody knows these polymers are used in medical, metallurgy, current applications. Nowadays, the textile industry is mostly doing this cleaning fabric, self-cleaning fabric. They are researching about self-cleaning fabric. These self-cleaning fabric are like this. They are anti-sweat, anti-smell-proof. That's why maybe some military men or medical doctors which are far apart from their vicinity, they can use that material so that no irritation, no need of changing their clothes is required. This sulfonated ketone and polyvinyl alcohol aqueous solution, these are also used in polymer industries, Excite solution. Now you all are also aware about paints. These paints are made up of polymers. These polymers are also some in the range of antibacterial. Some are waterproof, water resistance type of paints are coming in the market now. These are also the new researches of materials. Now, the future, I'm concluding my session. The future is bright for the material science and engineering. As far as I can imagine, you can correlate the mechanical, electrical, civil, physical, chemistry, and metallurgical, geological, every area in material science. The main prospect of material science is the discovery of new materials and their engineering that can change the landscape, design the parameters and constraints. With the better tools and deeper understanding, fundamental materials possesses a new ground which will dip to design the new material with better properties and I think usability with easiness. Everybody want to use the material which have low cost and low maintenance. That that the researchers want to discover the cheapest material with low maintenance. Currently, this is happening actually at macro level, micro level, and nano level. The graphene. Graphene is the hero of material science nowadays. The graphene is graphene plays a role which is used in every application, I think. Here, I'm not discuss the role of graphene because I'm not in the research of graphene, but I know what is the properties of these graphene. Now, I'm concluding my this session. If somebody have any question, any query, you can ask me. Just do the write your questions in the chat box. I will try to answer all of you. Thank you so much.
Thank you, ma'am. There is a one question I think we get
Yeah,
from Agent Patel.
Agent Patil. Can
Can
material
material
science can be combined with robotics? Yeah, of course. Material science is combined with robotics. As I said, semiconductors, it is used in computers, nanochips. You must heard about this Silicon Valley. Okay, this is we can research uh, much deeper to combine these material science to the robotics. Yes, we can combine this.
so thank you. If anyone have any query, you can ask by yourself. Just unmute yourself and ask the question directly to the presenter, or you can also write the question in the chat box. I don't think so we are having any
Yeah.
further query or question from the attendees. So I think we should wind up this session. So thank you, ma'am, for
Thank
giving
you
us
so
your
much.
precious time and sharing your knowledge on material sciences. And I would also like to thank to all the attendees who for their patience listening for us and for today's session. And we hope we are going to bring some new topics for our next session or next lecture uh, in the total of share and grow. So, and for one more thing, for feedback form and your certification, you can direct mail to the Jitsu. Mail ID he has already provided in the chat box. So thank you so much. Thank you to all the attendees, and thank you for the performance. Till then, stay safe, stay happy, stay at home. Thank you so much. Good night.
Thank you, Eco Foundation, for giving me this opportunity. Thank you, Vishnu, for this. And have a nice day and stay safe, stay home.
Thank you, ma'am.
Hello, AM Vision. Do you have any queries? Hello.
Huh?
Do you have any questions? Actually, you turn on your mic. That's why I asked.
No, sir.
Okay, it's fine. Okay, thank you all. Thank you.